Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this December month lecture series, we are going to discuss about Bode plot and frequency response analysis. Okay, and the first and foremost thing is rules for constructing Bode plot. First one, represent the open loop transfer function in the standard time constant form. Substitute S equal to j omega in the above equation. Find the cardinal frequencies and arrange them in ascending order. Consider the starting frequency of Bode plot as 1/10th of minimum cardinal frequency. Consider the starting frequency of the Bode plot as 1/10th of minimum cardinal frequency or 0.1 radian per second, which is smaller value, and draw the Bode plot up to 10 times maximum cardinal frequency. Again, draw the magnitude plots for each term and combine these plots properly. Draw the phase plots for each term and combine these plots properly. Okay, why do we need Bode plots? Normally, we use Bode plot, polar plot and Nichols chart for analyzing stability of a particular control system. From the Bode plot, we can say whether the control system is stable, marginally stable or unstable based on the values of these parameters. The parameters are gain crossover frequency, phase crossover frequency, gain margin and phase margin. Okay, we consider only 4 elements: gain crossover frequency, phase crossover frequency, gain margin and phase margin. Okay, what is this phase crossover frequency? Name itself says phase crossover frequency. The frequency at which the phase plot is having the phase of -180 degree is known as phase crossover frequency. It is denoted by omega pc. The unit of phase crossover frequency is radian per second. Gain crossover frequency, the frequency at which the magnitude plot is having the magnitude of 0 dB is known as gain crossover frequency. It is denoted by omega gc. The unit of gain crossover frequency is radian per second. Okay. The stability analysis of control system is based on the relation between phase crossover frequency and the gain crossover frequency. First thing, if the phase crossover frequency omega pc is greater than the gain crossover frequency omega gc, then the control system is stable. If the phase crossover frequency omega pc is equal to the gain crossover frequency omega gc, then the control system is marginally stable. If the phase crossover frequency omega pc is less than the gain crossover frequency omega gc, then the control system is unstable. Okay. First, gain margin. Here the gain margin gm is equal to the negative of the magnitude in dB at phase crossover frequency. Gm equal to 20 log of 1 by mpc, where mpc is the magnitude at phase crossover frequency. The unit of gain margin is gm in dB. And what is this phase margin? Formula for phase margin is pm. It is equal to 180 degree plus 5 gc. Here 5 gc is the phase angle at gain crossover frequency. The unit of phase margin is in degrees. Okay, first thing, the gain margin gm, the formula is 20 log 1 by mpc. Here mpc is your magnitude at phase crossover frequency. M is your magnitude, pc is your phase crossover frequency. So magnitude at phase over cross frequency is mpc, phase crossover frequency mpc. Here the unit is dB. And for phase margin, it is 5 gc, phase angle at gain crossover frequency. Here the unit of phase margin is in degrees. Okay. We have studied 4 main elements of Bode plot to analyze the stability of a control system. First one is gain crossover frequency, second one is phase crossover frequency, third one is gain margin, and fourth one is phase margin. Okay. Here, if both gain margin GM and the phase margin PM are positive, then the control system is stable. If both gain margin GM and the phase margin PM are equal to 0, then the control system is marginally stable. If the gain margin GM and the phase margin PM are in negative, then the control system is unstable. Okay, see here, we have discussed 4 elements: phase crossover, gain crossover, phase margin and gain margin. Based on these 4 elements, we can analyze the stability of any control system, whether it is stable, unstable or marginally stable. Thank you.